Hello, hello, Rufa here, and we're going to talk about 1D kinematics. So this will be part one of our mechanics unit in AP Physics. So we'll get this going here. All right. So mechanics is the study of motion. And mechanics is divided into two major areas of study. We have kinematics, which is motion that's not involving forces. In reality, it does involve forces, but we're going to have very idealized conditions for now. And then there's dynamics, which is motion that is involving forces. That'll be kind of our big unit, and almost everything that comes after is going to involve dynamics. Okay, we will first be concerned with kinematics, and then dynamics is going to come soon after. So first we're going to start with 1D or one-dimensional kinematics. So that's motion that's in just one plane or one straight line, whether that's horizontal or vertical. So that means no trigonometry for now. Lucky you. Our goals today are to understand the relationships between displacement, velocity, and acceleration, and to solve story problems involving displacement, velocity, and acceleration. So I really enjoy this meme. It's distance versus displacement. It's our, if I can get my video moving out of the way here. There we go. Velociraptor equals distance raptor over time raptor. But you savvy physics people will soon learn that it should be displacement raptor over time raptor. And we'll talk about what that means in a minute here. All right, so distance is the separation between 2 points. So it's your total travel, okay? It's a magnitude. It's what we call a scalar. And we're going to learn more about scalars and vectors when we get into 2D kinematics. So if you're not sure what that means, that's okay. We'll talk about that later. All right, so distance would be like you travel from Chicago to New York and then down to Florida. Your distance is going to be the distance measured between Chicago and New York and between New York and Florida. Now, displacement is very similar, but there's a very important difference to displacement. So displacement is the difference between your start point and your end point. And it doesn't matter what came in between. Okay, so displacement would be the distance between Chicago and New York, but maybe you traveled Chicago and then you went down to Indiana and then you did a big circle in a loop and then you went up to Canada and then you went back down to New York. Your displacement would just be the distance between your start point in Chicago and your end point in New York. So displacement is a vector, which means it has both magnitude, so just a number and a unit, but it also has a direction. So that's very important for displacement. And again, we're going to dig more into that when we do vectors later on. Okay, so displacement can be represented by this delta x. So delta is a Greek letter, and it looks like this little triangle here, and it means change in. So delta x, or change in x, is your displacement, and that equals x sub f minus x sub naught. So your displacement is the change in your final position minus your initial position. And sometimes you'll see people draw this differently. Sometimes you might see delta x is equal to x sub f minus x sub I for initial. Sometimes you'll see x sub 2 minus x sub 1. And my calculus class people, you might see something like x prime minus x. So there are all sorts of different ways of representing this that you may see. Okay, we're going to erase that and then go back to the pointer. Okay, so my daughter likes to play with My Little Pony. We watch ponies together. And let's suppose that one of her favorite ponies, Rainbow Dash, is traveling from Ponyville to Canterlot. We'll say it's 100 kilometers away, and then travels back to Ponyville again. So Rainbow Dash is going from Ponyville to Canterlot, and then all the way back, and it's 100 kilometers. between the cities. So I want you to think about for a minute, pause this video, and think about what is her distance traveled in kilometers. So pause it, think about it. I hope you're pausing it. Better be pausing it. All right, so her distance traveled in kilometers would be the 100 kilometers to Canterlot plus the 100 kilometers back. So 100 plus 100 is 200 kilometers. And then her displacement in kilometers. Let's sit and think. Think about how displacement is the difference between your start point and your end point. So where is Rainbow Dash starting? Where is she ending? So pause the video, think about it, come up with a guess before you get my answer. Okay, so hopefully you paused it and gave it a try. So Rainbow Dash is starting in Ponyville, Pville. And then she goes to Canterlot, and then she comes all the way back to Ponyville. So this is her start. And her end is also, or her finish is also in Ponyville. So if she's starting and ending in the same place, and displacement is the difference between your start position and your end position, then did Rainbow Dash actually have any displacement? No. Displacement, delta x, or sometimes people write it as d, is 0 kilometers. Okay, again, mind blown. Displacement is the difference between the start position and the end position. So if she started at point 0, say Ponyville is at point 0 on a little map or something, and Canterlot is at point 100, she starts at 0, ends at 0, that means displacement is 0. Yes. All right. So now we're going to talk about speed and velocity. So I move my little video out of the way again. So speed is represented by a lowercase v, and speed is the distance traveled in a given time. So it's a scalar, and it's represented by this equation, v equals d divided by t. So speed is distance divided by time. Okay, time we always give in seconds, remember, as we talked about our standard units, and distances are always given in meters. Again, recalling our standard scientific units that we discussed last week. So velocity and speed are pretty similar. Velocity is represented by a lowercase v as well, and sometimes you'll see it with a little bar over the top. When it has a little bar over the top, that means it's a vector. You might not always see that. It's kind of like a little bar with an arrow over top. Okay, so velocity is your change in position over time. It's not distance over time, it is displacement over time. So velocity has direction. It's a vector. Okay? So velocity is equal to change in position, or your displacement, over change in time. And you might see this as delta d, you might see it as delta x, you might see it as delta y. Any of these values can be used to represent position. All right, so we've got an example here that I want to work through with you. We have a student who travels, let me move my picture there. We have a student who travels 11 meters north and then turns around and travels 25 meters south. If the total time of travel is 12 seconds, find the student's average speed and the student's average velocity. So again, pause this video, take a moment to work this out in your notebook, give it a try, and then you can pop back in and see the solution. So I'm going to go ahead and get that started. Hopefully you've paused it. Okay, so the student is going 11 meters north. Okay, so 11 meters, and then turns around and goes 25 meters south. Okay. So again, typically when we're doing this, we would represent these two as positives or negatives. North usually is a positive, and south is usually negative. So when we're taking the difference between the two, it's a good thing to keep in mind. Okay. So we have a total time. Time is 12 seconds. Oop, don't want that. Time is 12 seconds. All right. So average speed is going to be the distance over time. So V equals D divided by T. And our distance is the total distance traveled. So 25 plus 11 is 36 meters. And we're dividing by the time, which is 12 seconds. And that's going to be equal to, let me pull out my calculator here. Oh, I lost my calculator. Let's see, 36 divided by 12 is going to get us 3. That's something I should have known. So we've got 3, and then our units are meters per second. Okay, so that is our speed. That's our answer for letter A. Okay. Now, I'm going to erase that so that you guys can see the rest. There we go. All right, so now we're going to do velocity. Remember, velocity is displacement over time. So this student's gone 11 north and 25 south. So we got to take 25 minus 11. So 25 minus 11 is 14. So that is our displacement. And our time is 12 seconds. So now we have 14 divided by 12. So we're going to go ahead and type that into the calculator. 14 divided by 12 gets us 1.16 repeating. So we've got 1.17 meters per second. If you want to be sig figgy with this, then you're going to want 1.2 meters per second is our velocity. And notice how these two numbers are very different. Remember, we found 3 meters per second for speed, but our velocity is 1.2 meters per second. So again, it's really important to consider displacement versus distance and to be careful which you use in a problem. So I'm going to go ahead and erase this, and we will move on to units and acceleration. So AP units, there we go. AP units, AP uses X for horizontal position and Y for vertical position. But in other places, like in your book or sometimes in my notes, because I'm used to using this, you may see D sub X for horizontal position, and you may see D sub Y for vertical position. They all mean the same thing. Okay, but it's important for you to be consistent and for you to try to use the same units in each problem. So just make sure you're being consistent problem to problem. Okay. All right. Acceleration. So acceleration is the rate at which velocity changes over time. Okay, so if velocity changes in magnitude or direction or both, you're going to have acceleration. So acceleration is going to be a vector quantity. So if we've got our little rainbow dash here and she's going from rest to some speed, that means she's accelerated. If she's traveling at a constant speed and then turns and goes back the other way, when she turns, that's a change in direction, so it is a change in acceleration. Important thing to keep in mind. Acceleration is given by your change in velocity divided by your change in time. So it's delta V over delta T. Remember that delta, that triangle means change in. So change in velocity is your final velocity minus your initial. And change in time is your final time minus your initial. And typically that's just going to be given as one full time. All right, so units for acceleration. Units are meters per second squared. Remember, for velocity, it's meters per second, meters divided by seconds. Acceleration is meters divided by seconds squared. If you're looking at your equation, we have a velocity over time. Velocity is distance over time, and then that's divided over time. So it's distance over time, which is meters divided by second, which gives you meters per second squared. Okay. Rookie mistake. It's really easy to accidentally leave out that little squared up top, that meters per second squared. So make sure that you're adding your squared so that people know you're talking about acceleration instead of velocity. Okay. So there's some examples here, and we can work a couple of them just so that you can see what to do. So we have a sprinter that starts from rest and reaches a speed of 12 meters per second in 4.25 seconds. Find the sprinter's acceleration. When we're starting with problems like these, one of the things that I like to do is write down my givens, write down what I know, and then write down what I'm looking for. And that can help me either find the right equation or, figure out what else I need in order to find the answer. Okay. It's also nice to draw a picture sometimes. So when problems are more complicated, drawing a picture is super helpful. So we have a sprinter, they start from rest. So our initial velocity is 0 meters per second. And they reach a speed of 12 meters per second. So our final velocity is 12 meters per second. Okay. And then our time is 4.25 seconds. Okay. And we're looking for the acceleration. So remember, acceleration is equal to change in velocity over change in time. So my change in velocity is going to be my final velocity minus my initial, and then divided by time. And apologies for writing all over the rest of this board here. So final is 12 meters per second. My initial is 0, and then divide that all by the 4.25 seconds. Okay, so I'm going to go ahead and calculate that out. We've got 12 divided by 4.25. And that gives us 2.82. 2.8. No, we'll write that elsewhere. Equals 2.82. And then our units for acceleration, remember, are meters per second squared. Okay, so that's our answer right there. All right, and when you're solving problems, again, I like you to draw a box around the answer so that I can see where your answer is, because you notice I've got all this, chicken scratch gobbledygook up here, and it's easier for me to see which of the mess is your answer. Okay. All right, so I think we'll do number 2. So a car starts from rest and accelerates at 15 meters per second squared for 3 seconds. What is its top speed? So it starts from rest. So that means our initial velocity is 0 meters per second. And we have an acceleration. It accelerates at 15 meters per second. So acceleration is 15 meters per second squared. There we go. And we've got 3 seconds, so that's our time. And again, notice I'm underlining here. Sometimes it's helpful to underline stuff in the question to help you find the answer. And we're looking for its top speed. Okay, so we're looking for VF. V sub F is question. We don't know what it is. Okay, so we're going to set up our equation here. A equal to VF minus V naught divided by T. Now remember, I like you to solve for the variable first. So don't plug in your numbers right away. Let's solve for VF here. Okay, let's try to find VF. Okay, so what we have to do is get rid of the T. So we're going to do times T to move it over to the other side. And then we have this minus V naught. So we need to add V naught, and that's going to equal V final. Okay, V naught is equal to 0, and so we're left with A times T. So we have 15 times 3. Go ahead and type that into your calculator. 15 times 3, and that should get you 45. Okay, so 45. And remember, we don't just have naked numbers. No naked numbers. We don't want naked numbers. They don't go out in public all naked. They need units. Okay, so 45 is our final velocity, so we should have units of meters per second. Okay, so that's our final answer. All right. So that'll do us for acceleration. And next, in the next section, we are going to be doing, oh, let me put my pointer back on. In our next section, we're going to be talking about graphing motion. So tune in for that next. And if you have any questions, send me an email. Bye. Maybe. There we go.